Hello, and welcome to Game Gems. Today, we're going to look at one of the ways to create a scene transition as seen in games like Smash TV or The Binding of Isaac. There are multiple ways to achieve this effect, so maybe I'll cover them in a future video if there's interest. Here's how the transition looks in-game. As the player bumps into one of the 4 doors located in the walls of the arena, the scene shifts to the new room, and once the transition completes, the player respawns inside. As we're primarily focusing on the animated scene transition, I won't be explaining things like player movement, initializing the new room with enemies, or setting up custom spawn points. Those things are unique to your game, and there's already plenty of tutorials out there covering those basics. So, let's get started. At its core, we're simply using a pair of nodes, a room node and a player node. The player node is parented to the room node, as would be anything else in the room. When the player hits one of the doors, a new room is generated off-screen, and then the existing room and the new room are moved into place. Once the old room is done transitioning, it's destroyed and the player is reparented to the new room. The first thing you'll need to do is to set up your room. For sake of simplicity, we're assuming our dungeon extends infinitely in all directions and is generated on the fly. Simply add 4 static body 2Ds to your arena, one for each wall, and give them an appropriate collision shape. I used collision polygon 2D because I don't want the collision shapes to block the doorways. Next, create 4 door triggers with area 2Ds and collision shapes set to type rectangle. Save the scene as room.tscn. Attach a script to your doors and call it door. Give it an actual class name in your script. We're going to need it later. Attach the onBodyEntered signal from your doors to your door script and let it generate an onBodyEntered method. This is where we'll trigger the transition. Wait a minute though. Who handles the transition? Where will it be in the scene tree? We have a problem here. The transition will be handled by the room's parent, our game or world class, and that class is in a separate file. How do we connect our door's signal to it? Well, we can do this in a couple of ways. We can have the door emit a signal itself, we can get the door's parent's parent, but all of these are redundant, break encapsulation, or otherwise rely on stuff we shouldn't have to care about. So let's use a message bus. The message bus is a programming pattern that simplifies message handling in an engine like Godot, and Godot makes it really easy to implement. Simply create a script file called messenger, or whatever you like, and add it as an autoloaded script under the project settings, like so. This class is now available by name to any other object in the game. Our message bus has to handle one signal, appropriately called trigger transition, so let's define it. It takes a single parameter called direction, which is going to be one of the cardinal compass directions, north, south, east, or west. Let's go back to our door script and finish filling it out. We'll need an enum to define the compass directions so we can pass them to the signal. Define one called compass and give it the appropriate values. Then, export a variable of that type so that we can tell each individual door which direction the transition is being triggered for. Once that's done, assign the correct compass direction to each door. The north door gets north as its direction, south gets south, and so on. Now that our doors have directions assigned, go back to the onBodyEntered method and tell the messenger to emit its trigger transition signal with the parameter equal to the door's compass direction. We're almost done with our door. We're also going to add a static helper function that returns a particular vector depending on the compass direction. This will help us calculate where the new room spawns. There may be a more compact way to do it, but one of the cardinal rules of game development is, get it working, then make it clever, if you have time. And if you're doing this professionally, you'll never have time, so bonus. Anyway, ultimately we're going to multiply this vector by the room's default starting position to get its spawn position. Okay, the room object, its doors, and message bus are done. Now we can start hooking up our game objects and make the actual transition. Create a scene called game, or world, or whatever you want, and set it as the default scene. This is our game world. Drop a copy of the room scene into it and adjust its center point so that it's at the center of our display window. Doing it in this way keeps us from having to set up a camera. We'll just use the game's viewport. We'll also need a player. For the sake of expediency, create a character body 2D, give it a sprite 2D, I used our good buddy logo.svg, and attach a basic movement script. Here's the one I used, ripped straight from the Godot character body 2D tutorial. Also, add a collision shape 2D and make it large enough to cover the player. You should also set the walls, doors, and player each to their own collision layers, and the door should only collide with the player. Add a single Boolean property to the player script called acceptInput, and wrap your input check in an if statement that only processes input if this variable is true. This is the flag we're going to use to freeze the player during room transitions. I also exported a speed variable to adjust the player's movement speed, but that's not super relevant. You can define it locally if you want. We now have everything we need to implement our room transition. If you haven't already done so, attach a script to your world node. Add an export variable called roomTemplate and drag your room.tscn file into it in the inspector. This is the prefab we're going to use to spawn new, empty rooms. Next, we'll need variables to hold references to our existing room, the new room, and a tween for each. The tweens will be how we manage the transitions. Finally, grab a reference to the player node so that you can move it from room to room, and drag it directly under the room node so that it is a child of the room node. In the world's ready function, connect to the message bus's trigger transition signal and assign it a callback called onTransitionTrigger. We'll define it in a moment. Next, grab the room node you just dropped into the world and assign it to the current room because, well, it's our current room. Now, define your onTransitionTrigger function. Since Godot's tweens are not intended to be reused, we want to delete them at the end of the transition process. In so doing, we can check if a transition is in progress by testing whether or not the reference variable is equal to null. If the current room's tween is equal to null, that means there's no tween going on, so we can start a new one. Instantiate a new copy of the room template and assign it to the next room variable. Set its origin equal to the current origin plus the direction vector gotten from the door's directional helper method multiplied by the room's origin again. Wait, what? When a new room spawns, it has an origin equal to the one set when its scene tree was saved, which, if you did it right, is the center point of the viewport. My viewport is 1280 by 720, so the center point is 640, 360. The new room spawns in the direction the player is facing, and its current center point is going to be a full room length away from the current one. The reason for this is because from the center of the room to the edge is half the length of the room, so we need to double that. The vector we get from the door is that number of these half room length adjustments, so all we have to do to find the new center point is multiply the original room's center point by that adjustment to get the new offset, then add that offset to the original center point. Note that if you're not spawning new rooms on the fly, you won't need to do this, but you can never have too many tricks in your bag. Anyway, once we have the room spawned, we need to add it to our world. We can't do this in a signal callback, so we use callDeferred to tell Godot to wait until it's able, then call the world's addChild method with the parameter of our newly spawned room. Next, we need to freeze the player until the transition is done, so we set their acceptInput variable to false so that they stop taking input. After that, we create two tweens. Tweens are objects that interpolate a property from a starting value to an end value, so they're perfect for our purposes. Specifically, we want to move our rooms by interpolating their position from its current position to its new position. In the case of the new room, we want to move it to the current room's position, so we tell the tween to do that via the tweenProperty method. We also add a callback to the tween, which is a function that fires when the tween is complete. We're using a new feature of Godot 4 here, the lambda function. Lambda functions are functions that you don't have to define with a name. You can simply pass the function definition right into the function call as a parameter. In our case, we want the tween to set itself to null when it completes. We do a similar thing to the current room, add a tween to move it from its current position to the inverse of the new room's spawn position, which is calculated the same way the new room is, but we subtract the result instead of adding it to reverse direction. We also add a pair of callbacks to do a few things to clean up the transition, which we'll look at next. First, we attach a method called onTransitionComplete as the first callback. In that method, we remove and delete the current room, then assign our new room as the current room. When we do our next transition, we'll tween both the new room, which is now the current room, and whatever room we spawn then. We then reparent the player to the new room and give them a new spawn position in the center of the room. This stops the player from immediately triggering a new transition when they respawn in their old spot on top of the door. Finally, we unlock the player's controls by setting acceptInput back to true. And that's it! You now have a basic, endless dungeon that stretches out into infinity and won't eventually kill your computer's memory. If you found this tutorial useful, don't forget to like the video and subscribe to my channel for more game gems. See you next time!